lesson is going to be on the characteristics of a function. The goal for this lesson are to learn how symmetry affects a function and also some strategies for curve sketching. Now for our first task, we are told to explain how symmetry can be used to analyze functions. So what is symmetry? Symmetry can be described as the ability to divide a shape into at least two identical portions. There are two types of symmetry. The first is even symmetry, which involves the graph being symmetric about the y-axis, and it also occurs in even functions. The second is odd symmetry, and this involves the graph being symmetric about the origin, and it occurs in odd functions. Now, for a function that has even symmetry, f of negative x is equal to f of x. So over here, f of this positive point, which is x, is equal to 0, and f of negative x is also equal to 0, so you can see that they're both equal to the same value. For a function that has odd symmetry, it should be true that f of negative x is equal to negative f of x. So for that, f of negative 0.5, which is 2, would be equal to negative f of x. So f of x is 0.5. So f of 0.5 would be negative 2. And so the negative of negative 2 gives you positive 2. And so they're both equal to each other. So conclusions that we can make about symmetry is that once we find out that a function has symmetry, we can use our knowledge of each type of symmetry to mirror points when sketching a graph. So for example, with even symmetry, if we know the values for positive x, we can know for the negatives as well. So it helps us with sketching. Now for our second task, we need to describe some strategies that can be used to approach a curve sketching problem. And right here is just a list of some of the main strategies that you can look out for. The first is key features, symmetry, intervals of increase and decrease, loci extrema, and then end behavior. Now, when trying to find key features, things we need to look out for are x-intercepts, which is when f of x is equal to 0. So let's say we're told to sketch this function, and we're just given the equation. You first want to find the x-intercepts of that function, which is you set the equation to 0, and here you can see how the x-intercepts look like for the graph, and then you also want to find the y-intercept, which is when x is equal to 0, and here when x is equal to 0, the y-intercept is at 2. Then you also want to try to identify if there are any asymptotes. For this function, there are no asymptotes because the function is defined and there's no discontinuity at all. It's a continuous function. The second thing you want to look out for is symmetry. And in this f of x function, this is even symmetry. So if you knew that it was even symmetry, you would know that f of x has to be equal to f of negative x. So these are points that show that f of x at negative 1 is equal to f of x at 1. Another really important thing to look out for is intervals of increase, which is when f prime of x is greater than 0. So you need to find the derivative of the function that you're given. And when f prime of x is greater than 0, that's when the function is increasing. When it's less than 0, the function is decreasing. So you also want to try to look for the local extrema points, and for that you look out for the local min using also f prime of x. You set f prime of x is equal to 0, and then you look for where f prime of x is greater than 0, and then you know you have a local min in this case there's two local mins. And then for local max, you also still set f prime of x is equal to 0, and you search for when f prime of x or f double prime of x is less than 0 to give you your local max. Last is end behavior. So you look out for when f of x is approaching infinity. So like when the x values are increasing in the positive direction, you see what is the end behavior of the function. So this is just increasing continuously. And then you also look at when f of x is approaching negative infinity. So the x values are increasing in the negative direction. You see what's happening to the graph. Now just a little pop quiz to test you. Which has an odd symmetry and which is an odd function? You can pause and figure. So in this case, both of them have odd symmetry, but only one of them is an odd function. It's this one, and that's because it has point symmetry occurring at the origin. This one doesn't have it occurring at the origin. Thank you for watching.